Okay, good afternoon, everyone. This will be our lecture 3 for the fourth week, and our topic will be correlation. So, correlation is also dealing with the relationship between two variables, and almost the same as what we did last week. Le following or lecture last week. Yeah, covariance. So covariance in file last week. So correlation is similar but a little bit stronger because covariance we can only find the positive or negative or no or zero which is no covariance at all. Ole malosi angala ole disadvantage la le covariance. It will the strength or the relationship. We only know if it's positive, but what kind of positive? Yeah, same as negative. We don't know if it's strong or is it weak. Uh, so that's where correlation is very important. Eka umeka ko a positive and eka umefui be positive strong or positive weak. Ilela the footing the three types. Positive correlation is when you calculate and your value is closer to one. So correlation for is only between -1 and 1. Yeah, kako value say mo. And if you got a negative value, yang away low, negative means a negative correlation. Yeah, I have a pela wa lakalakali one. The negative one, it means it's a weak. It's a very weak correlation. So same case with positive one. I have a pela kalakal positive one. Yeah, ingalola yeah, a strong correlation. So and if I pay mawala kalakal zero, well, it's a correlation. Yeah, they explain that like for example, when the correlation coefficient is greater than zero, it means that both variables are moving in the same direction. When it is positive one, it means that the two variables being compared have a perfect positive relationship. When one variable rises, the other one falls, or the other one decreases. When the other one rises or falls in the same magnitude. Okay, yeah, same with negative. When the correlation coefficient is less than zero, it is called negative or inverse correlation. This indicates that both variables are moving in the same direction. In other words, any variable between 0 and -1 indicates that two securities are moving in opposite direction. The relationship is said to be perfectly negative correlated when it is -1. Yeah, okay, so in the graph, this is a strong positive correlation. Yeah, laka umalenga, and this is a weak one. This is a strong negative correlation. This is a weak negative correlation. So this is moderate. Moderate means fiololo negative correlation. So it's between strong and weak. So we call it moderate. Yeah. Random, so it's no correlation at all. So there's a quiz online. Feel free to attempt if you can. It's just the reading of the graphs. How how you read and interpret the graph given. I think there are four. I'll show you after the lecture how to do the quiz. Okay, so calculating correlations by hand or by varied data. So we are given this data. So we can see it's positive. It's a positive correlation. Yeah, but not every time you can write a graph. You can draw the graph. It's time consuming. So instead of drawing the graph, we can use alternatives like calculations. And by using our knowledge of correlation, we can find if it's a positive strong or positive weak, or negative strong or negative weak, or no correlation at all. But so far from the graph, because it's only four data, but if you plot the graph. But what if you're dealing with hundreds? of data, or maybe just 10 data. That's a hassle to draw the graph. So that's where we do the calculation. So it's simple. Only R represents the correlation coefficient. So 1 over n minus 1, sum of x values minus the mean divided by the standard deviation times y values minus the mean of y divided by standard deviation of y. And we are also given the mean of x and the standard deviation of x, also the mean of y and standard deviation of y. Okay, just a quick sub-in of values. So, kako values is 4. So, 4 minus 1 is mode 3. So, 1 over 3 for akili. If I pupong o mea after, so you plus all this up before you multiply to 1 over 3. So 1 from x minus the mean, which is 2, divided by the standard deviation, which is 0.816, times y1 minus the mean of y3, divided by the standard deviation, which is 2.16, or same as 2.160, plus next 2 minus 2, divided by standard deviation, times 2 minus 3, 2 over y, minus 3 over the mean. And that's how you do all the calculations. So as you can clearly see, less 0 e 2 minus 3 is 0. So you know 0 times any number 0 0 kuala there. Pengavila e or here is 0 times 0 ring 0 kokoi malayang o lua it's just this these two they multiply lema 1.134 and 0 lua lema 1.702 from this one. You add them up and then you multiply by 1 over 3 and I got my R, which is 0.945. And as you can see, R is very much closer to 1, which represents or which means that R is a strong correlation, a strong positive correlation. So with only calculations, we can manage to find out if it's weak or strong without drawing or plotting any graph. Okay, that's it for this calculation. So I have some activities here for you. Like lectures, because I've uploaded this video lecture as well as the PDF file. So you can open up the PDF file and try and calculate these three. And with the given variables. Yeah. So our states are the difference between covariance and correlation. Covariance is a measure to show the extent to which given two random variables change with respect to each other, and correlation is a measure used to describe how strong, the strength, or correlation, the given two random variables are related to each other. So covariance, it is a measure of correlation, or the correlation is defined as the scale form of covariance. Yeah, scale comes from scalar, vector and scalar. Kaulit case of physics. Yeah, let's with scale. So scale the direction and magnitude. No need to detail. The value of covariance lies between or the covariance. It's a limitation of values. It's any number between any two numbers, negative infinity and positive infinity. But for correlation, it's just between -1 and 1. And lastly, it indicates the direction of the linear relationship between the two variables. And for correlation, it means the direction and strength. So that's the important difference. Direction and strength are correlation, but covariance is just the direction. And that's the difference between covariance and correlation. And that's our lecture for today. And I'll see you when I see you.